slope, if you will. This is not off to a good start. I tell you that. John, what do we know about slope? Anything?
Slope intercept or whatever.
Slope intercept, sure. What is slope? We have many different ways to describe the same thing here. First of all, in math, they designate the letter M. Not that you can't use M for other things, but quite often when you see the letter M in math, it is slope. Why do you suppose they don't use the letter S for slope? Because we use the letter S probably for side, like when you do a square, S and S. So slope is, yeah, and John said, well, I know when we do slope intercept, y equals mx plus b, that's always the slope right there, so you see that coming up there. What technically is slope? When you go skiing, you hit the slopes, Ellen Christ, it's?
The rise over the run.
It is the rise over the run. When you graph something, it's the rise over the run. It's really something that indicates the rate of change or how fast something changes. Okay. Like if you're talking about the ski slope, okay, if something has more slope, what's that mean? I mean, you've got your mountain or your hill. More slope, Nick, means it's
Steeper.
okay, it's steeper. In other words, that the rate of the change of the ground is more. The ground changes a lot faster over a distance. You know, you've got this, like here, this is really steep. You know, in this distance here, the ground changes an awful lot. In this distance here, the slope is less because it doesn't quite change as much. Now, we got positive and negative slope, that's all different here, there, or whatever, but rise over run. You can also say that the slope is the, think about the top being how far up over how far over, which is also the change in y, okay, over the change in x. Which is also going to bring us to our next little thing here, the slope formula, which actually doesn't appear for another couple lessons, but I'm going to give it to you now because we've talked about it for so much. I think you're capable of it. Slope formula looks like this. Here's my letter M. M equals, in math, how do you show change in something? Change is a subtraction problem. So it looks like this. y2 minus y1 over x sub 2 minus x sub 1. And that will equal slope. What was this line for? At least I hope that's right. Let me write that down, I'm going to make sure. That is the slope formula. Got that now, put it in big letters there. I'm going to get a new screen here. In other words, this. If you were given this, they say to find the slope given these 2 points. And it doesn't matter, you could give me the points. Lucas, give me a point.
1,
1 comma what?
1 comma 2.
1 comma 2. Nick, give me another point.
3 comma negative
3 comma negative 3. Those are my 2 points. Now you are always, ladies and gentlemen, feel free, although I wouldn't do this, feel free to graph those 2 points. Here's 1 comma 2 and 3 negative 3, and you get this beautiful little line right here. Okay, you can always use the old school. Uh-oh, did I do something? You can always
You,
Oh, I'm
it's-
sorry, it's 1 comma 2, not 2 comma 2. Oh, great number. Thanks, Jack. That was the first mistake I made today. 1 comma 2 and 3 minus 3. So you got this line right here. You can always make your little triangle from this and do the old way of finding slope, which is to count how far up it is over how wide the triangle is. Remember that? Yeah, somebody just nod your head in agreement there. But you don't want to have to do that every time because it gets to be a little old, a little monotonous and time consuming. You can use this slope formula that we just talked about where the slope equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Which means this, you're just going to subtract the 2 y values, get an answer, and subtract the 2 x values, get an answer, and that will be your slope in fraction form. Okay? And it doesn't matter, this is x1, because x always comes first, y sub 1, x sub 2, y sub 2. Okay? Always, you have to match the two. If you put a sub 1 for this one, the sub 1 has to be in the same parenthesis. Okay? I could call these x2, y2 if I wanted to. It doesn't really matter which one you call 2s and 1s as long as they're both the same thing. You know what I'm saying, Vern? Okay, you can make these the 2s and those the 1s. You're still going to get the right answer, but these two have to be the same little sub thing. You can't put x2, y1 there. It'll mess you up. Okay, so really all you're doing is subtracting the y things, and again, I would strongly suggest, and probably only about 3 of you will take me up on this, but that's just the way it works. I would strongly suggest putting parentheses in for those things, because otherwise you'll get mixed up a little bit with your negative signs there. So y sub 2 is negative 3 minus y sub 1, which is 2. X sub 2 is 3 minus x sub 1, which is 1. And once we do this problem, negative 3 minus 2 is a negative 5. And 3 minus 1 is 2. You can't reduce it. This will be your slope. That's what the letter M is. I guarantee you if I count up this triangle here, guess what I'm going to get? It is 1, 2, 3, 4, 5 high. This triangle is 2 wide, and it's going downhill, so it's a negative slope. Lauren?
Isn't that more work though than just counting?
Huh?
Wouldn't it be better just to count?
You want a race? You want a race?
No, but you
I'll
just
put a
did
couple.
it.
I'll put a couple points up there. You draw the graph, draw the line, count the triangle, and I'll do.
So I'm saying like after you draw the graph, and then you just count it, and then it's like that.
But you don't have to draw the graph after.
Oh.
You don't need to do any of this ever. You can just take the 2 points and put it here. Skip the whole graphing part. I'm just saying that's what the old school way we did it. Kind of older more. Especially if you were to get to a point, you know, where we had something like 10 comma negative 2 and, you know, negative 8 comma 14. If I asked you to give the slope of that, by the time you made all your little things and you got a piece of paper and did all that, it's a pretty simple little process. Again, slope equals, you know, and it doesn't matter as long as you keep them consistent. If you make this, you know, I'll switch it around. I'll make this the 2's. It doesn't matter. Okay, it's y2 minus y1 over x2 minus x1. Maybe you want to put a little number underneath so you remember which one is which. y2 is negative 2. Y1 is 14. X2 is 10. X1 is negative 8. Negative 2 minus 14 is a negative 16. 10 minus a negative 8 is actually 10 plus 8, which is 18. Your slope is negative 8/9.
So we don't have to draw the graph.
No. No, I was just trying to get you to see the connection between one and the other. If you did do the graph, it would look like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, negative 2. And negative 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Here's the line. And it would just be a little cumbersome to draw this whole triangle and count all those squares. Does that look like a -8/9 slope to you? Sure it does. Now, take a look, please, at page 200. Well, wait, let me see here. Take a look at page 259. Because not always is slope given to you in that exact thing there. Let me draw this. If you look at example letter B, they give you a table that looks like such, where it says, it compares miles to feet. Miles to feet. 1 mile is 5,280 feet. Is that what they're saying? Oh, no. Sorry, I gave you the answer there. Why did they do that? Can I change that? I want a different example problem. I don't like that one.
That's the other one.
No, turn the page. Let's do the measure and drum kicks. This is for Nick Shanks. Or no, this is for John Nyer.
Sorry, I had water sprayed.
I'm sorry, sometimes I open it and it like squirts. It's not my fault.
You can be in water, don't you worry. Measure and drum kicks. Measure. John, what is a drum kick? Do you know of such a thing? Have you ever heard that phrase before?
Yeah,
Have you? Oh, what's a drum kick? I don't know.
it's just when you go.
Wow, complicated stuff. Okay, and they ask you to use this table used to find slope. And here is the basic gist of that. It's the same thing we just did, where this, when you're given a table, generally speaking, the top is the x values, and the bottom is the y values. Okay, so think about it not in terms of a table, but in terms of making points out of it. In other words, you've got this point 1, 4, you've got the point 2, 8, you've got the point 3, 12, and you've got the point 4, 16. And it doesn't matter which 2 points you use to find your slope, you just pick 2. You'll get the same answer regardless. You know, maybe I'll pick, let's just pick 2 and 8, and 4 and 16, which by the way, you probably can tell me the slope of that without doing this, but let's do it. Let's make this the 1s and this the 2s. Slope is y1 minus, or y2 minus y1 over x2 minus x1. What is this? 16 minus 8 over 4 minus 2. 16 minus 8 is 8. 4 minus 2 is 2. The slope of the line, if you were drawing it, would be 4. Or 4 over 1 if you like. But that's pretty much makes sense because what do you do to x to get y? If I write an equation of this, what would it be? Y equals 4 times whatever x is. Slope always comes in front of the letter. M equals 4, slope equals 4, line equals 4. You kids are really excited about it. I'm going to stop there because, well, I'm going to give you a quiz and a worksheet. Is that okay?
Yeah.
Wait,